Okay, hello everyone. Guys, I'm just going to go through this practice test number 3. It was kind of like an exit ticket the day before the test. I'm just going to set them up for you though. I'm not going to give you the answers. There's this first one. This is the fundamental counting principle. Again, 5 appetizers, 8 beverage, 9 entrees, 6 desserts. Let's multiply them all together. 5 times 8 times 9 times 6. 6, 9, 8, 5. That's it. All right, multiply them together, you get your answer. All right, number 2, we got 5 factorial. That's 5 times 4 times 3 times 2 times 1. All right, you can use your calculator or use Desmos. Put in 5 factorial. All right, what does that equal? All right, number 3, 8 factorial over 3 factorial. That's a fraction. The top, 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That's the top, 8 factorial. The bottom is 3 factorial. 3 times 2 times 1. Right? The 3, 2, 1 cancels out. So multiply those numbers together, you'll have it. All right? All right, 4 trophies on a shelf. How many ways can you arrange it? Again, it's 4 factorial. We're arranging all of them. 4 times 3 times 2 times 1. And again, it's an arrangement. You can think of it as a permutation. 4, we're arranging 4. From 4, arranging 4. It's all of them, so it is 4 factorial. Because this is 4 factorial divided by 0 factorial. 4 minus 4. This is just 4 factorial. Right? All right, number 5, 7p3. What this is saying is choosing from a group of 7, how many ways can I order 3? How many ways can I arrange 3? Or how many arrangements of 3 can I make choosing from a group of 7? All right, that's just equal to the first 3 Look at 7 factorial and list the first 3. 7 times 6 times 5. That's it. Again, you can put that in your calculator, guys, if you want. All right, this is the combination. And this is how many groups of 3. Order doesn't matter. Just how many groups of 3 can I get picking from 5? In other words, from 5, pick 3. How many ways can I do that? Well, guys, the top is 5 times 4 times 3. The first 3 starting with 5. That's the top. And if this was a permutation, we'd stop right there. But this is a combination, so there's less. All right, we have to divide by 3 factorial. Read 3 times 2 times 1 if you want to put the 1 in there. The 3's cancel out. 20 on top divided by 2 is 10. Oops, well, you can see what it is. Try not to give you the answer. I guess I just did. All right, how many ways can you arrange letters list? 1, 2, 3, there's 4 letters. It's 4 factorial. And look at it, in case you haven't figured this out yet, here's your calculator. Turn it on. Let's go 4 factorial. 4, hit the 4. Guys, the math button is right there. Math. See where I'm touching? Math. Right there. Math. And then I'm scrolling over with my arrow, right down here, my arrow. I'm scrolling over to this PRB. That means probability. You got the permutation, the combination, and the factorial right there. You can scroll down and hit enter. I hit the number 4. I just hit 4. And the factorial just pops in there. And I can hit enter, and that gives me my answer. 4 times 3 times 2 times 1. That's what it is. All right. Or guys, use Desmos if you want. Just put 4 and exclamation point. It'll come right up. All right, guys. The next one is arrange letters in the word combo. How many letters? 1, 2, 3, 4, 5. 5 letters. But this one, guys, the O has a repeat. Just look for how many groups that repeat. So the first one is O. That repeats twice. So you have to go 2 factorial on the bottom. Nothing else repeats. That ends up being 5 times 4 times 3. Because the 2 and the 1 cancel out. All right, number 9. 8 runners in the qualifying race. All right, guys, this is the one that's a combination. Order does not matter. Just the top 3 finishers move on. Order doesn't matter. So it's a combination. 8 runners. Top 3. All right, put it in your calculator. That's 8 times 7 times 6. Divided by 3 times 2. All right. 3 and 2 disappear. And 6, I think that's it. Yep, I see it. All right, number 10. 8 runners in the final race. How many ways can they finish? Now, guys, first, second, third. Order does matter. Order does matter here. So instead of the C, it's a P. This one's a P. And that's 8-3. Again, 8 runners. Order 3. 3 in order. How many ways can I do that? Arrange 3. Up here, just give me any 3. All right. Again, each group can be arranged 6 times. That's why we divided by 6. But down here, oh no. Down here, we just go 8 times 7 times 6. All right. We don't divide by 2 times 3. We don't divide. We need to count every permutation, every arrangement. But there's more of them here. All right, number 11. Robbie goes on a trip, brings some books along. 5 books in the suitcase. 9 books to pick from. Right? Order does not matter. Order does not matter. We're just picking. Picking 5 from 9. All right, that's a 9. Right, go ahead and do that. Put in your calculator. Guys, I'm going to see if I can just quickly call up Desmos. I'm not sure if it's going to work in case you haven't seen Desmos. Let me just see. This might not work. No, it's not going to work, guys. Use Desmos if you can't do your calculator. Here, I'll put this one in the calculator. Again, this is 8. I'm sorry, it's 9 C5. So 9. I put the 9 in first. In Desmos, you don't do that. In Desmos, you put 9 comma 5 in the end. But again, now there's a 9 in there. I hit the math button. Math. I scroll over. The combination is number 3. And the second number was 5. See, I'll put that in there, 9C5. Enter. That's the answer, okay? All right, got a few we have to identify. Either a permutation, combination, or fundamental counting principle. This is the book club. Choice of 6 books from a list of 30. Just from 30, give me 6. All right? Order doesn't matter. It's a combination. This one, a corporation has 8 members, board of directors, but we're electing a president. vice president, treasurer. Right? Order matters. Permutation. This one, popular brand of sweatshirt, 5 colors, 3 styles, independent events. They don't affect each other at all. Just multiply them together like a tree diagram, 5 times 3. Fundamental counting principle. Guys, I have to hurry because I'm almost out of time here. All right, y'all, this is the hardest part. What's the total number of possible outcomes if you flip a fair coin 7 times? Guys, it's 2 to the 7th. All right, flipping a fair coin 7 times. How many ways to exactly 3 tails? Flipping a coin 7 times? It's a combination. 7, 3. Put in your calculator. What's the answer right here? It's what you got for number 2 divided by what you got for number 1. That's what this is. That's the probability. All right, last one. That's worth 3 points on the test, too. All right, the next one, guys, how many ways can I arrange president, vice president for the whole class? It's a permutation, arrange. Permutation, everybody, 24 students, 24 students. I'm arranging 3. President, vice president, treasurer. This one, I'm just looking at the boys. Again, I'm arranging 3, but only the boys. It's 14 boys. All right, so again, it's a permutation. And, again, the final answer here, whatever you got for number 2, divided by whatever you got for number 1. It's the same as the one before this. The final answer, you just divide, okay? That's it, guys. Thanks. I hope it helped.